All right, so here is the fourth and the last model that I would like to discuss. I have two consumers, and then the input is not labor, but it's one of the consumption goods. All right, and the agents have initial endowments to begin with. So here is the example, the numerical example, and hence the example specific assumptions. So I have two agents, A and B. The utility functions are Cobb-Douglas, two consumption goods, X and Y. So by the way, it's always better when you have more than one agent to name those X's and Y's, with their agent-specific name. So let's call this XA times YA, and this is XB times YB. All right? So just to be on the safe side. Then the initial endowment for agent A, so she has 0 unit of good X and 4 unit of good Y. And agent B has 2 units of good X and 0 unit of good Y. It's just a numerical example. And then there's a firm, and the firm produces X by using Y. So Y is a consumption good. So it's sold on the market, but it's also an input, and the firm uses Y to produce X. So the YF corresponds to how many Y the firm is going to use, and XF denotes how many good X the firm is going to produce. Agent B owns the firm, all right? And then in equilibrium, in Walrasian equilibrium, what's the price ratio? That's the question. And what's the allocation? And then the third question is the final allocation Pareto optimal. All right, so two questions. What is the price ratio? Is the allocation, is the equilibrium allocation Pareto efficient? I mean, verify it. Well, by the first theorem of a theorem of welfare economics, the equilibrium allocations must be Pareto efficient, all right? So therefore, the answer to this is the allocation Pareto efficient. Yes, verify it, fine, we can do that. All right, so here is the question. And again, the way we are going to solve it is exactly the same. The firm maximizes profit by taking the prices as given. The consumers, both consumers, maximize their utilities subject to their budget constraints, again by taking prices as given. And then in the third condition, the supplies and the demands we found in step 1 and 2 must clear. There should be no excess demand and no excess supply. So those should be the equilibrium prices. So it's not W divided by P, but rather Px divided by Py. All right, so Px is the price of good X, Py is the price of good Y. All right, so step 1, the firm's problem. Well, the firm's problem is the following. So the maximized profit. So what is the profit? So here, the firm is producing only X. And so it's selling only good X. So it's going to be Px times Xf. The firm does not sell, cannot sell YF because it doesn't produce it. So this is the revenue minus the cost. Obviously, if you're using YF many input, you have to pay this much money. All right? So revenue minus cost, this is your profit, subject to the constraint, the production constraint. Well, the total number of X you can produce has to be equal to square root of total number of input Y you use. Okay? So that's it. How do I solve it? Well, use the constraint. We know that YF has to be equal to XF squared. And whenever you see Y, F, just plug this. So the profit is going to be Px times XF minus YF times, I'm sorry, not YF, Py times XF squared. And so the first order condition, if you are trying to maximize this, means take the derivative with respect to XF, set it equal to 0, and solve for XF. So if you take the derivative with respect to XF, you're going to get Px minus 2py xf equals 0, hence xf equals px divided by 2py. All right, so this is the supply for good x. Well, how many good y this firm is going to demand? Well, it's the square of this thing. So it's the px squared divided by 4py squared. All right, so this is the demand for good y. All right, very good. So this is the firm's problem. Oh, the profit, don't forget that. I keep forgetting. So the profit is the px times this thing. So px squared divided by 2py minus yf times py. So I just multiply this by py. So this 4py squared and py will cancel out. So it's px squared divided by 4py. So therefore the profit is px squared divided by 4py. All right, so that's what profit is. Okay, so the consumer's problem, step 2. Consumer A. So what I do is maximize XA times YA, right? Subject to the budget constraint. So be careful about budget constraints because that's, I think, setting up these optimization problems, I think, are the most important part of those problems. The rest is just engineering, all right? If you set this problem wrong, obviously your engineering, regardless of how brilliant it is going to be wrong. So you have to be clear about this step. The subject to the budget constraint. So what is the budget constraint? The expenditure has to be equal to income. Let's remind ourselves, consumer A doesn't own the firm, so there's no profit for her. And well, what else? She consumes X, first of all. So px times xa, all right? And then she's going to demand some y, right? That's true. Py times ya. So that's it. So she's going to demand some y. She's going to demand... So regardless of how many x and y she has, you may think, oh, she already has 4 units of good y, so she's not going to demand those. But remember, our intuition is the following. These agents come with those endowments, go to the market maker, sell those endowments to the market maker with the prices at px and py, get cash. If they own the firm, they get the profit. And then with those money, they go back to the market and pay the price and again buy good X and good Y. That's the intuition, all right? So for that reason, with the expenditure, maybe this is 0. I mean, I don't know. At the end, she may actually want to consume no 0. Or maybe this is going to be 4, but nevertheless, it's expenditure because we are going to include the endowment as an income. So therefore, this is expenditure, okay? I hope that is clear. So this is income. What about the expenditure? I'm sorry, this is expenditure. What is her income is coming from the endowment. So it's 0 times px plus 4 times py. So this is how much money she gets selling her 4 good y to the market. All right. So the thing is, she doesn't own the firm, so she doesn't get pi. But then, does she get any benefit from selling y to the firm? So again, here the idea is the following. The consumers do not sell their Y's or X to the firm. They sell it to the market maker. And then the firm goes to the market maker and buys the Y from the market maker. Okay? So for that reason, the agent A does not sell any Y to the firm. It sells everything to the market maker, everything that she owns, and then goes to the market and buys it. So just to be clear, the consumer A's optimization problem is to maximize utility subject to the budget constraint. And here her expenditure is this and her endowment is this. Her sort of wealth out of her endowment is this. and she doesn't own the firm, therefore pi does not get into her budget curve, budget set. So therefore this is her optimization problem. So how can I solve her optimization problem? Well, simple. Well, here you can use the substitution method, obviously. So how can I do that? So write YA as a function of, so leave YA alone. So it means 4PY divided by, right, this is 0. So 4PY or minus PX times XA divided by PY. All right. So the utility is going to be maximized, therefore, this. So XA times 4PY minus PX times XA divided by PY. So you choose XA positive, non-negative, so that this is maximum. So how do you do that? You take the derivative. So it's 4PY minus 2PX XA divided by PY equals 0. So if you solve this, you are going to get 4PY equals 2PX XA, and hence XA equals 2PY divided by PX. All right, so this is how much good A, consumer A, will demand. Well, her demand for good Y is therefore this thing, which is 4PY minus PX times this, which is 2PY divided by PY. So it's 2PY divided by PY. So it's 2. Well, let's be clear so that I don't make any mistake here. Give me a second. Yes, that's correct. Okay, very well, because I am inclined to make mistakes and I didn't want to make mistakes. So I'm just checking with the answer. So this is how much good Y and good X consumer A will demand. Well, symmetrically, I'm going to solve the consumer B's problem. So once again, maximize utility, which is XB times YB, subject to her budget constraint. PX times XB plus PY times YB, this is her expenditure. And her income is, well, her initial endowment. So it's 2 times PX plus 0 times PY. So 0 times PY plus the profit, pi. All right? So because she owns the firm, the profit doesn't depend on XB, YB. So I can just treat it as a constant. So once again, write YB. Leave YB alone, so it's going to be 2PX plus pi divided by minus PXXB divided by PY. So this is what YB would be. So if you plug that here, the max is going to be XB times 2PX plus pi minus PXXB divided by PY. So the first order condition, so let me continue somewhere here. I can't erase these really. So, so if I take the derivative of this thing with respect to XB, it's going to be 2PX plus pi minus XB 2PXXB divided by PY equals 0. So therefore, send everything to the right. So send this 2PXXB equals pi plus 2PX, and hence XB equals 2PX divided. So I'm dividing both sides by 2PX. So it's going to be 1 plus pi divided by 2PX. Okay. All right. So give me a sec. All right, that's true, pi over 2px. And then if you plug this x value here, what you're going to get is px divided by py plus pi divided by 2py, I guess. Yes. So this is how much good Y consumer B would like to consume. All right. So that's good. So what do I have? I have following. So I am done with step 1, step 2, and what's left is step 3, the market clearance. So now I have to basically sum up everything, like who is the demand, who is the supply for who, etc. So this is what I'm going to do. All right. So the good X supply for good X. Well, first of all, good X supply is the initial endowment, 2 plus 0 plus XF, right? Because the firm produces X. So this is supply. The demand, XA plus XB, which is equal to, XA is equal to 2PY over PX. And then XB equals to 1 plus pi over 2px, where pi equals px squared divided by 4py. All right, that's good. By the way, here the xf equals px divided by 2py. Good. And then I'm done with this. Good Y, the supply, again, the total endowment 4 plus 0, plus YF. So YF is not a supply. And these are all demand, all right? So YB, YA, these are demand. So therefore, there's no further supply for good Y. And then the demand is going to be agent A, oops, it's not X, it's Y. Agent A demands, agent B demands, and the firm demands, because it's input, all right? So therefore, it's equal to, YA is 2, YB is this, PX over PY plus pi over 2PY, and then plus YF, which is px squared divided by 4py squared. All right. All right, so step 3 is the market clearance. I'm going to clear good X market. That constraint looks easier. So the supply is 2 plus XF. So 2 plus px over 2py. And then the demand is XA plus XB, so it's equal to 2PY over PX plus 1 plus pi over 2PX. So I'm going to divide this guy by 2 times PX. So it's going to be PX divided by 8PY. All right, so this is what it should be. Well, remember, at the end of the day, I need to find the price ratio, PX over PY. So let Py equals 1 as the good Y is the numeraire good. Well, this is a trick that you can definitely use. So good Y has a price of 1. So I normalize it, then just find Px, all right? So it's easier. So if you do that, so first of all, this 2 and 1 will cancel, so you're going to left with 1. So 1 plus px over 2 equals to 2 divided by px plus px divided by 8. All right, so that's what I have. I can multiply, I can send this guy to the other side. So it's going to be 1 plus 3px divided by 8 equals 2 divided by px. All right. Add these things. 8 plus 3px divided by 8 equals 2 divided by px. So do the cross product. It's going to be 8 px plus 3px squared equals 16. well, this is not something nice. 8, so therefore, what I have is 3px squared plus 8px minus 16 equals 0. So, you know what? Well, the roots are 4 and 4, right? One of them is minus, 3 and 1. So I think this is minus, this is plus. So this is 3 times 4, 12, minus 4, 8. So therefore, this thing is equal to 3px minus 4 times px plus 4 equals to 0. All right. Yeah, it seems like that's true. So this cannot be 0 because the px is always non-negative. So this has to be 0. So therefore px equals 4 over 3. All right. That's exactly how I would solve it. A nicer solution would probably be if you just assume py is equal to 3, therefore, then I'm sure you're going to find px equal 4. All right? So that's exactly how we solve. If you equate the supply and demand for good y, again, you should be getting exactly the same thing. Well, let's try. So the supply here is 4. The demand here is a bit more complicated thing. It's 2 plus px over py plus pi divided by, so this thing divided by 2py. So it's going to be px squared divided by 8py plus px squared divided by 4py. So if I need to simplify this, send 2 to the other side. 2 equals px over py plus this, if I add them up, it's going to be 3px squared divided by 8py, all right, something like this. So here, that's what I'm going to try. So let px equals 4, py equals 3, all right? If you do that, 2 equals, well, let's see, if px py plus 3 times 16 divided by 8 times 9. So this is 3, this is 2. So this is 6 over 3, and it's equal to 2. Yes, exactly. So therefore, I mean, rather than py, so remember, all it matters is px over py ratio. So what I did here, I pick py as 1, and I found that the px has to be 4 over 3. So therefore, px over py ratio is 4 over 3. All right, so all the prices that satisfies this ratio is in equilibrium. So what I did here, just to verify that the market will clear on good y, I picked the price of good y is 3, and hence the price of good x has to be 4, because it clears the market. All right, so this is exactly how we solve it. I hope that was clear.